This is a presentation by Iqra Ramzan produced in September 2023 for Unit 17 Human Immunity. This is a presentation. These are the topics I'll be covering today during this presentation. Section 1. The first part of this presentation covers Section 1 of the assignment, showing an understanding of non-specific defences against disease. An infection occurs when microorganisms such as bacteria and viruses invade the body, typically throughout the mouth, nose, or throughout cuts in the skin. Bacteria are single-cell organisms which can cause illnesses such as meningitis, pneumonia. Viruses are different to bacteria in that they need a host to replicate and survive. Diseases caused by viruses include common cold and chickenpox. Skin diseases such as athlete's foot and ringworm are caused by fungi, and parasitic diseases such as scabies and malaria are caused by parasites. Infections can be transmitted via direct contact, indirect contact, insect bites, and throughout food contamination. Indirect spreading of infection occurs when the bacteria or virus is transmitted to a surface for another person to touch and transfer to their own body, typically via their mouth. It is thought that a cold virus can survive on indoor surfaces for several days, but its ability to cause infection drops rapidly over time. Davies. Insect bites can also transmit infectious disease via carrier known as vectors. This is a common transfer method for bugs such as mosquitoes and ticks. Food can also become contaminated with bacteria such as E. coli, which causes food poisoning and can make a person feel very unwell. First line of defense, the innate immune system. The body has 3 lines of defense to protect our cells and vital organs from infection. The innate, non-specific defenses are mechanisms which function to prevent pathogens from entering the body or function to eliminate invaders. These defenses are genetically programmed and happen autonomously. The skin is the largest organ in the body and is our most prominent physical barrier of defense. The epidermis of the skin provides a waterproof covering which prevents penetration of microbial organisms, chemical irritants, and toxins. Should the skin become grazed or cut, it can heal by itself by quickly forming a scab to act as a temporary barrier while the skin underneath heals. The hot saltiness of the skin and the presence of normal flora are also innate defenses, as these conditions do not provide the right environment for bacteria to grow. Physical and chemical barriers. The body is also able to fight microorganisms using enzymes found in the secretions of internal mucous membrane. These membranes are responsible for filtering infectious agents, pathogens, and allergens, whilst allowing nutrients to pass through. Stomach acid, pancreatic enzymes, bile, and intestinal secretions can all be found in the gastrointestinal tract, and each provide a chemical barrier against infection. Movement of chyme through the digestive system via peristaltic contraction also helps to remove microorganisms which may otherwise cause harm. Pathologists believe up to 70% of our immune system is located in a gastrointestinal tract, which demonstrates how important it is to keep a healthy gut. Pathogens can also enter the body through the nose, which is why our nasal cavities are coated with sticky mucus that traps the microorganisms before they can travel into the airway. Although this is not 100% effective all the time, so humans also have tiny projections called cilia on the lining of the airway, which seep sweet particles up to the throat where they can be swallowed into the stomach. An area prone to infection in females is the urinary tract. Although it is effective barriers to infections, the female urethra is short and can provide a passage for external bacteria to travel into the bladder. However, most bacteria will be flushed out when the bladder empties, and this is true for both sexes. Inflammatory response. When injury occurs, the body creates an inflammatory response, which is the innate immune system response to damage or infection involving several cellular events. The physical effect includes dilation of blood vessels, forming gaps in the cell wall, allowing large blood cells to pass through, increasing blood flow and creating inflammation. The site may appear swollen and feel warm to touch because of the extra blood and protein attracted to the infection, and is often painful because of the inflammation. Inflammation is one of the second lines of defense. It is vital as it isolates the area, stopping damage from spreading whilst promoting healing. In the diagram, we can see an example of where the skin has been damaged and chemical signals have been released from the cells to alert phagocytes, or more more specifically macrophages, to move into the area to absorb the bacteria into a vesicle called a phagosome. This process is known as phagocytosis, which is a second line of innate defense. Phagocytosis. When the phagosome fuses with lysosome, a phagolysosome is created. The phagolysosome is filled with digestive enzymes which destroys the content, and that ends the process of phagocytosis. The macrophages develop from the monocytes when inflammation occurs, and they are of vital importance to the immune system. Macrophages are a variation of cytokine cell which protect the body from microbial infection by blocking or destroying pathogens. Cytokines and antigens. The next section of this presentation covers the sections 2 of the assignment brief showing understanding of specific immunity. Cytokines are complementing proteins produced by various cells to enhance the immune response through signaling, mediating inflammation and immunity. There are more than 30 complement proteins in total which activate when triggered by the presence of a pathogen. For example, they interact with each other to create a cascade of reactions, attracting phagocytes to remove unwanted particles, initiate inflammation, and produce protein to attack invading organisms. Antigens are molecules found inside the pathogen and often help the pathogen to enter the body. Antigens cause an immune response in the body by communicating to the cells that there is an attack. Macrophages have antigens, but neutrophils do not. The second line of defense, the adaptive immune system. Neutrophils are the most abundant white blood cells and are often the first to react to the site of infection or injury. These medium-sized cells attach to the walls of blood vessels and block germs from accessing the bloodstream. Monocytes become macrophages to carry out the phagocytosis process. Description of other immune cells can be seen on this slide here. Lymphocytes. Lymphocytes are another type of white blood cell which can be found in lymphatic tissues around the body. There are two types of lymphocytes, T cells and B cells. T cells mature in the thymus gland and function to help destroy problematic cells such as pathogens or damaged cancerous cells. Helper T cells, the most common type of T cells, regulate most of the immune system functions in the body by releasing lymphokines that stimulate other T cells to grow and attack foreign bodies. B cells mature in bone marrow and produce antibodies or immunoglobulins when activated. Plasma cells are a type B cell that secrete antibodies into the circulatory system to provide immunity, and memory B cells store the memory of the specific antigen in the lymph nodes to be used again if required. Immunoglobulins. Immunoglobulins have many functions, including recruitment of immune cells, neutralization of toxins, and removal of antigens. As you can see, the chains of the immunoglobulins are arranged in a Y shape, with the smallest chains having the ability to bind it to antigens. The immunoglobulin is named after the type of heavy chain they have. The common variations of immunoglobulins are shown on the slide here. IgG is the most common immunoglobulin. It is the only immunoglobulin that can pass from mother to baby via the umbilical cord and placenta to pass on some protection. IgE attaches to the cell in the mucous membrane and skin, where they can release histamine. Allergic reactions such as hives, hay fever, and asthma are symptoms of IgE-mediated reaction. IgM is capable of destroying the invader all by itself. Similarly to IgG and IgM also activates a complement pathway, and these two variations can combine as an antitoxin against toxin of diphtheria, tetanus, botulism, and anthrax microorganisms. Self-recognition and tolerance. Antigens found throughout the body and also in harmful pathogens are used by the immune system to signal whether it should attack or not, depending on whether the antigens are foreign or self. Foreign antigens are those found in pathogens and will be remembered by B cells when they are recognized in the body, triggering antibody production when identified. All nucleated cells have unique surface molecules that identify themselves as self. They are known as self markers and named major histocompatibility complex molecules, or MHC. The immune system has self-tolerance, which means it will not attack cells with these MHC class 1 identification tags, although in rare cases, a person may develop an autoimmune disease which occurs when B or T cells become activated against self-antigens, but it is known why this happens. Hypersensitivity. Hypersensitivity is the occurrence of an abnormal immune response caused by repeated exposure to a particular antigen. Hypersensitivity diseases can be grouped based on their underlying causes, as seen on the slide with some examples. Autoimmune diseases can occur all over the body and cause fatigue, muscle aches, lower fever, and inflammation. Rheumatoid arthritis is one of the most common autoimmune diseases described by the NHS in 2019 as a long-term condition that causes pain, swelling, and stiffness in the joints. Unfortunately, there is no known cure for rheumatoid arthritis, but some symptoms are treated with medicine and supportive therapy, such as physiotherapy. Surgery is also an option for correction or joint problems. It is believed that women and smokers have an increased risk of triggering an autoimmune disease. As well as people who have family history of autoimmune disease, another common autoimmune disease is a multiple sclerosis, or MS, defined by the NHS in 2019 as a condition that can affect the brain and spinal cord, causing a wide range of potential symptoms, including problems with vision, arm or leg movement, sensation, or balance. There are two types of multiple sclerosis, with the most common being relapsing remitting MS, which presents an episode of new or worsening symptoms for a period of time before slowly improving over a similar time or period. Treatment for MS includes a short period of steroid medication or treatment of specific symptoms such as problems with bladder control and muscle stiffness. Organ transplant. An organ transplant is carried out to correct organ malfunction with a healthy organ given by a donor and is often a life-saving procedure. Unfortunately, the immune system does not always accept the donor organ, viewing it as a foreign agent, and the process that follows is known as rejection of transplanted organs. As discussed earlier in the presentation, the immune system is capable of recognizing antigens on the surface of cells as foreign or self. In the case of a transplant, the immune system may not recognize the antigens present on the organ, and it may initiate an attack. To improve the chance that the body will accept the new organ, physicians will try to closely match both the organ donor and recipient using a procedure called tissue typing. A medicine containing monoclonal antibodies is also used during and after surgery to fight off specific T cells known to rejection. If rejection does occur, it will be as in one of these three shown on the slide here. The most common rejection seen is acute, as all recipients will experience some amount of acute rejection. An example of hyperacute rejection would be if a recipient is given the wrong blood type. Section 3. This is the final section of the presentation, covering Section 3 of the assignment brief, showing an understanding of biology of vaccinations. Active immunity describes the resistance to a particular disease through creating antibodies, either naturally or artificially. Natural active immunity develops from exposure to a specific pathogen, such as a common cold. There are many strains of common cold, but once the body has been exposed to one, the immune system creates antibodies to attack the virus, which are then stored in memory B cell as immunity to that particular strain. Artificial immunity is gained when antigens are introduced to the body via a vaccine, which causes a reaction in the immune system. This reaction stimulates the production of antibodies and memory cells in the same way as the active response. If the body should become infected with naturally occurring antigens after vaccination, the body can attack and destroy them before symptoms of the disease develop. This is called immunological memory. Natural passive immunity is when the antibodies are passed from person to person, such as in this case of a mother and unborn child. Immunity passed on in this way can provide protection for up to 6 months. Artificially induced passive immunity is acquired when a person receives antibodies made by someone else in the form of transfusion or injection. Protection from artificially induced passive immunity lasts for only a few weeks, as the immune system is not stimulated in the process. Immune response to vaccination. A vaccine contains a small amount of a pathogen which stimulates antibody production in order to provide immunity. The pathogens in a vaccine can be specifically treated live cells, harmless fragments, toxins produced by pathogens, or dead pathogens. The NHS in 2019 says vaccines teach your immune system how to create antibodies that protect you from diseases. It's much safer for your immune system to learn this through vaccination than by catching the disease and treating them. Once your immune system knows how to fight a disease, it can often protect you for many years. The first time a pathogen is fought in the body, the process that occurs is known as the primary response. The lymphocytes identify the antigen, and then it takes time for the plasma cells to produce an appropriate antibody. Often symptoms will take hold of the body during this time. If the body encounters the same pathogen again, the body will react with a secondary response, which is significantly quicker than the primary response. The memory cells are able to quickly recognize the pathogen and produce the required antibodies to fight the antigen, often before symptoms occur. In an article for the Vaccine Knowledge Project 2019, measles is described as a highly infectious viral disease which can lead to serious complications such as pneumonia. The chart here, sourced from Public Health England, shows the number of recorded cases of measles from 1940 to 1995 in England and Wales. As indicated on the chart, the first measles vaccine was introduced in 1968 and had a dramatic effect on the number of cases. A second vaccine containing a measles pathogen known as MMR was introduced in 1988, causing a further decline in record cases. Data from Public Health England shows that no more than 2 people per year have died from measles from 1999 to 2017. Between 1995 and 1999, a total of 10 people died age 10 plus. In the article for the Vaccine Knowledge Project, it is claimed that the number of children receiving the MMR vaccine dropped in the 2000s, and this reduction is blamed for the several outbreaks since this time. According to the article, 2016 cases of measles were reported in 2012 and 1,287 cases reported in the first 6 months of 2013. Herd immunity is a mode of passing on immunity to members of the community who cannot be vaccinated, for example, newborn babies or people who are unwell, without them needing to come in contact with the pathogen either naturally or artificially. The concept of herd immunity arises from the belief that if the majority of the population are protected with a vaccination or natural immunity, it is less likely infectious and can spread. There are numbers of problems that can occur during an outbreak before the population reaches a level of immunity high enough to reach herd immunity. For example, pathogens can present with different variants of antigens, making it difficult for the body to protect against all the specific antigens. Plus, pathogens have antigenic variability, and this provides the same problems as antigen variants. Transmittably, the severity of the microbes in the pathogen can also affect the threshold of vaccinations required to provide herd immunity, as some infections are passed easily from person to person and some demographics suffers more than others. Herd immunity is considered more difficult to achieve in current times as the world is more globally connected than ever before, and this makes us vulnerable to global pandemics proven by coronavirus outbreak in 2020. Measles, polio and whooping cough were common causes of childhood death before vaccines were introduced. The World Health Organization says without vaccines we are at risk of serious illness and disability from diseases like measles, meningitis, pneumonia, tetanus and polio. The WHO estimates the vaccine saves between 2 to 3 million lives every year. In 1979, the WHO declared smallpox has been eradicated by a worldwide immunization program, and polio has not been seen in Europe since 2002. Another example of worldwide vaccination program is that COVID-19 coronavirus, which was identified in the later months of 2019, and vaccinations became in the UK in December 2020. This vaccination program is ongoing, but at the time of writing, 54.7 million vaccinations have been given in the UK and more than 1.37 billion doses has been administered worldwide. The vaccination program for children in the UK includes 11 plus vaccination, which covers diseases including diphtheria, tetanus, polio, measles, mumps, rubella and influenza. These vaccinations will be given in predetermined stage in the child's life and will be carried out by health visitor, nurse or GP. To increase vaccine uptake over the years since vaccines were first introduced, the NHS have included pharmacists to the list of medical professions who can administer a vaccine. It is thought that this would make it easier for adults with career and family commitments to find time to attend a clinic to get a vaccination. Some people choose not to be vaccinated, and the WHO says that this disrupts the effectiveness of the program and labels as anti-vaxxers. In a recent document In a recent document produced by the UK Government Scientific Advisory Group of Emergency Factors Influencing COVID-19 Vaccine Uptake Among Minority Ethnic Groups were listed. The research analysis paper states reported vaccine uptake has been low in areas with a high proportion of minority ethnic group population, and speculates that barriers to vaccine uptake includes perception of risk, low confidence in the vaccine, distrust, access barriers, inconvenience, and socio-demographic context, and lack of endorsement, lack of vaccine offer, or lack of communication from trusted providers or community leaders. This concludes my presentation. Thank you for listening.